What? Why so precise?
What are we going to be doing today?
We are going to be doing lots of definitions today. Hey Haley, what's up? All right, listen up. Hey, I started off by saying this chapter was the first. It's more of a medium chapter. Chapter 5 is challenging, right? Brand new stuff. It's weird. You never done it before. You have nothing to base your intuition upon. It's all brand new stuff. This one, you will have some things that you can at least use some intuition, previous knowledge. You haven't done this stuff before. Today is a seriously, it's more like a language arts class than it is a math class because it's nothing but definitions. You're going to do a tiny bit of math, like 2 plus 2 sort of math. But the rest is all going to be definitions. I'm going to warn you. The quiz that I give you on next week, it's all what we're doing today. And a couple of, no, not that. Behind you. No, we got to finish your test. All right, pass behind you. Okay, so today's class, you got to do 2 things. 1, you got to write down the definition, obviously. But then 2, you got to stop me if it doesn't make sense. I'm going to give you a definition that makes perfectly good sense in my math teacher brain. You know, you guys aren't, well, hopefully some of you turn into math teachers, but for those of you that are not math teachers, if my definition doesn't make sense, you got to stop me and say, that doesn't make any sense. Explain it better. Okay? Okay. Who?
Not even I know.
All right. That's why he didn't have me. All right. Hey, any questions? It's Friday, so Friday I just collect the homework. Any questions on the homework? All right. All right, could you grab an empty basket, go around and collect homework? All right.
It's the first time I actually don't know something. Oh.
Yeah, this is like, this is all brand new stuff. So here's the calendar. We will take a quiz on Wednesday. I'm going to tell you right now, the notes that you take today are like the majority of your resource card. If you show up on Wednesday, you're not going to pull this stuff out of your butt. It ain't going to happen. You're not going to remember any of this stuff. Some of it is kind of intuitive, but most of it is just brand new words that you've never heard of before. You're not going to make this stuff up on Wednesday. Please don't lose this. Please make sure you keep this so you can make a good resource card on Wednesday. You're going to need it. All right, it's going to be a worksheet today. Could I use the worksheet on the quiz? Well, the worksheet isn't going to have all the information. This is the information you're going to need. You're going to wind up with basically 2 tables. Those 2 tables tell you pretty much everything that you need. There's a couple rules, right? And that's what you're going to write for definitions. Well, it's entitled Adding and Subtracting. So it sounds like we're going to add and subtract. Well, today we're not going to do it, well, once or twice. But we're mostly going to give just definitions today. Monday we'll do the adding and subtracting. Here we go. In box 1, write this down. This is all brand new. This is all brand new. Borrow from somebody. Call it monomial. There's nothing about the word that monomial that screams, hey, this is what I am. This is why you need to have this written down. We define a monomial as a number, except it says real number. It's just a number, comma, or a variable, comma, or the product. Product means multiplication of a number and a variable. Okay, hey, do not, Porter, do not. You're going to get lost from this. A monomial is a number, comma, variable, comma, or the product of a number and a variable. So anytime you see a number, guess what you're looking at? A monomial. Anytime you see a variable, guess what you're looking at? Anytime you see 2x, that's a number times a variable, you're seeing a monomial. So the examples that if you need to write, why are you not clicking? So the examples, if you need to write them down, well, then the examples would be a number or a variable or the product of a number and a variable. Sure, I got it. I'm sorry. There we go. Like, why does it say polynomial? So a number, a variable, or the product. Product means multiplication of a number and a variable. Remember, a number could be any number, so it could be positive or negative. These are monomials. Mono meaning one. Meal meaning that thing. That's the made-up word. Monomial.
Why did you call it mon then?
Well, mono would just mean one. Okay. Clearly, if we have monomials, we must have. Here's what a polynomial does. You see these examples? You pay attention? Group these together with addition or subtraction. 2 plus x is not a monomial. Got two of them. It's a polynomial. X minus 2xy is a polynomial. So in the next box, that's what a polynomial is. Box 1b, 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 1b. You take any two or more of those monomials, you group them together with a plus or a minus, not multiplication, a plus or a minus. It's connected by addition or subtraction. If you see a plus or a minus, you're looking at polynomials, unless there's only one of them and then you got a monomial. If it says negative 3x, that's not a polynomial, that's a monomial. But if you see 2 minus 3x, Aiden, I'm not sure what you're doing, but you're not doing what I asked. Turn on, watch the board, write. Give me an example of a polynomial. Give me an example of a polynomial.
That is the example. Oh, that's the definition. I don't know.
All right, here's some examples. Notice, I got a monomial, 2x. I got another monomial, 3y. It's grouped together with addition. It's a polynomial. It doesn't have to be 2. It could be more than 2. Hey, polynomial. I got 3 monomials grouped together with either addition or subtraction. Those are polynomials. The rest of the book is about polynomials. Yes?
So polynomial has 2 numbers with a variable.
It doesn't have to have any numbers. It could just be variables, but those variables will be grouped together by addition or subtraction.
So it has to have at least 2 things.
Has to have 2 things.
Okay.
If there's one, it's a monomial.
Okay, cool.
But what do you mean by 2 things? I mean 2 things separated by a plus or a minus. Because check it out, 2x is technically 2 things, a 2 and an x. But it's not grouped together with addition subtraction, that's a monomial. You got it. Okay? Weird stuff. Weird stuff. Names, you look at the word polynomial, it doesn't scream, hey, it looks like this. Triangle, well, you can kind of tease what that means. Tri meaning, angle meaning, 3 angles. That's what a triangle is. 3 angles, right? You're not going to squeeze that out of polynomial. You get many if you know what poly means, but it doesn't say that that's what it means. Right?
So could just 2 plus 2 be a
2 plus 2, we would say, could be simplified to 4. It's a monomial. So notice none of these could be simplified. But 2 plus 2, I mean, it's a good argument, but we would say, well, because you could write that as 4. All right, here comes the first really, truly weird thing. On the quiz, I'm going to say, what's the degree of the monomial? If this is not on your sheet of paper, you will forget this. It's a simple concept. The degree of the monomial, and I've underlined it so you can really tease out the information. It means the sum. The sum means what?
Answer to an
The sum means what?
Addition.
Addition. You're going to add something. What are you going to add? You're going to add the exponents. Hey, we had an exponent class yesterday. We're going to add the exponents of the variables. We're not going to add the exponents of the numbers. We're only going to add the exponents of the variables. Kids will make a mistake because they will add the exponents of the numbers. I'll show you an example here in a second. It says add the exponents of the variables of the monomial. So I'm going to give you a monomial. You're going to add 2 or 3 numbers. It's pretty simple. Every year I have kids miss this. And it's like, what? How can you miss this? You're adding 1 and a 2. I will have kids miss this. The kids that are paying attention, nobody misses this. The kids that aren't paying attention, this is how I know. It simply says add the exponents, and I have people miss this. So let me show you an example. I'm going to give you a monomial, and I'm going to ask you to add the exponents of the variable. Hey, how many variables are here?
1.
Well, what's the exponent?
2.
There's nothing to add. The answer is 2. It's a degree 2 monomial. Hey, what are the variables here? X and Y. What are the exponents? What's it say to do? So what's the degree?
5.
There's nothing difficult here.
That's it.
I have kids miss this every year. You want to know why? It's not on the resource card and they don't remember. And the one that I will put on the quiz will be this one. Why? Because it tells me if you know the definition. What does the definition say? Of the. So what's the degree?
9.
Why isn't it 9?
Because it's just 4 plus 2 plus 3.
7 isn't a variable. So I don't care that it's 7 to the 4th power.
Just ignore the.
You ignore it. You simply add the powers of the variables. The answer is 5. Yeah.
If you just have x, y to the power 2, would you add?
I'll help you give an example here in a second. Yes, Chris.
Oh, no, okay, so we're going to ignore the variable on the 7 as well. Okay.
You got it. And the reason why is because we could tell you what that is simplified. We multiply 7 4 times. We can write that as a number without a power.
Yep.
Okay. All right. So her question was the one that we'll talk about here next. She said, what happens if there's no exponents? Well, wait a minute. Yesterday I said if there's no power, it's always. So what's the degree of this monomial?
2.
It says add all the variables, so it's 1 plus 1 is 2. Who's lost on that? So it says you look at all the variables and add their powers. What's the power of x? What's the power of y? We add all the powers, we get, that's the answer. Hey, what's the degree of this monomial?
4.
I heard 4 and 5. Which one?
5.
5.
Who's not getting it? We don't need to do 20 of these. Julie, what's this one? It says add the powers of the variables. So therefore, take a guess at what you think the answer would be. Boom. Good job. Guess what I'll put on the quiz? I'll put on one that looks like this, and I'll put on one from the previous, the one that looks like this. This will tell me right now if you know what you're doing. Right? Who's got this one? What do you got?
3.
And the last one? Are we okay? Are you telling me easy or hard?
Easy.
If you forget how to do it, it's crazy hard. But if it's on a resource card, you can forget it. Oh yeah, I remember doing that. You just add the powers of the variables. Quick note, we've already seen a little bit of this because we have combined like terms in the previous chapter. But it turns out when you want to add apples with apples, oranges, oranges, that's what we're talking about. You are allowed to add or subtract monomials that have the same variable to the same power. Pre-algebra, we rarely see different powers. Everything's either to the second power or everything's to the first power. Algebra 1, from now on, you're going to see things to the first power, things to the second power, third power, fourth power, so on. You can only group things together where the monomials have the same power and the same variable. I don't care if it says x squared and y squared. You can't add x squared and y squared. But you can add an x squared and another x squared because they are like terms. So let me show you how this works. I will give you a polynomial. You see it? Polynomial, two monomials separated by addition subtraction. Are these the same letter?
Yeah.
Are these the same power? You can add them together. How many we got?
9x.
Oh.
The rule is if you have the same variable and the same power, you add the coefficients or do whatever it says here, add or subtract. Okay? And by the way, you already did this last chapter, remember? 7x and 2x, you put 9x. Hey, can you add these together?
Yes. No.
Same letter, same power. So what's the answer? Because remember, there's always a 1, so the answer is this is combining like terms. Can you group them together?
No.
Yes.
Is it the same letter?
Yes.
Is it the same power? Can't group them together.
No.
Okay. So what's the answer?
4.
You just rewrite what's there.
Yeah.
Okay. Who's lost? Can you group them together?
No.
Can you group them together?
Yes.
You got to be careful on these. Everything's got to match. If this is if x is to the second power on this one, that's got to be the second power. If this is to the first power, that's got to be the first power. Hey, it matches up. So what's the answer?
It'd be 8x.
8x squared. Why? Who's lost?
I'm not subtraction.
Julie? There would be.
It is.
So I just choose not to write it. So this is 1 of these and 7 of these. You group them together, you got 8. Well, technically, this represents a number, and this represents the same number. I don't know how many of them there are, right? But they're there. So you just kind of think of this thing that I circled as an entity in of itself. So it's just this stuff plus this stuff. So we don't have to put a 1. There is a 1 there, by the way. You are correct. We just don't add that 1. Okay. I didn't say today was hard. I just simply said it's got lots of definition. Okay. Can you do those?
Yes.
Do them. Box 3. Who needs help? Nobody? Josie?
If you do, like, where would you put the exponents? Like, for the first one, would it just be -9 since you're minus?
That's it. And then write what's left.
-9.
-9. And then you put the variables.
But if variables are subtracting each other.
Well, technically, this is -2 times this. This is -7 times this.
So it'd be x to the second power.
Yes. Good question. Tristan, you got it? First one, the answer is? Because -2 minus 7 is 10. Because -2 minus 7 is 9. So what's the final answer?
That's all I got.
Well, then all you need to do is attach the variables and you're done. So what's the final answer? Just read what's there. -9. Give me the variables. Keep talking. That's the answer.
Oh.
Yes?
Yep.
When I think of this x squared y cubed as just, I don't know, apples. You got -2 apples minus 7 apples. Well, then you got -9 of them. Same or different signs?
Same.
So do you add or subtract? So 2 plus 7 is 9, -9. And then you have the variables. Lily, you got the second one? What do you got? Okay. Can't do it, so therefore, what's the answer? Yeah, you're not going to be able to put can on the quiz. You're going to have to write what the answer is. Yeah, you just simply write what's there. Because you can't, because this is to the third power, this is to the second power. Yeah.
How can you not? Can you just put a 1 for the
You can certainly put a 1, but it's got to be the same variable, same power. All right, Aiden, you got the last one? What do you got?
7 or 10 x.
So you tell me how you got 10.
I don't know. I just added for -1 to x to the 4th.
More negatives, more positives.
More or +1 to x to the 4th.
That is the answer. Now, should you put a 1, it's up to you. I wouldn't mark it wrong if you put 1x to the 4th power. Hey, you got to tell me who's lost. Good. Let's do some more challenging stuff. Here comes the most challenging. And it's not challenging, it's just definitions. This is where you're either going to have this on a resource card, get it right, or you're not, you're going to get it wrong. It turns out that polynomials can have two different types of names. Right? Two different types of names. We're going to write them all down. Okay. Recall that polynomials are a combination of monomials separated by addition or subtraction. Okay. First thing, write this down, and what are we on? 2D. No, 1D. Sorry, 1D. Is there a 1D?
The last box.
The last box. I just wanted you to have all the definitions next to each other. Okay. We had degree of the monomial. Now we're going to talk about degree of the polynomial. Degree of the polynomial. This is the one that always caused me problems because I knew it was different, but I couldn't remember the rule. And my math teacher didn't let me bring in a resource card, so I got this one wrong, even though I knew kind of what to do. You get a resource card, don't get this wrong. The degree of the polynomial is you look at all of the degrees of the monomials individually. Hey, I got this monomial has degree 2. Hey, I got this monomial, it's got degree 4. I got this monomial, it's degree 0. You pick whichever one is largest, and that's the degree. So you look at each monomial that you guys already told me what the degrees were. You pick whichever one is largest, that's the degree of the polynomial.
Oh, that's simple.
So I'll give you an example. So here's my polynomial, yes? What's the degree of that monomial? What's the degree of that monomial? What's the degree of that monomial? What's bigger, 2 or 1?
2.
So the degree of it is 2. You look at each monomial separately, you pick the biggest one. Here's another one. What's the degree of the first monomial? 5. What's the degree of the second one?
0.
0, right? So what's bigger, 5 or 0? The degree is 5. Stop me if you're lost.
I get it.
I know, it's pretty easy. So go ahead, Tristan. What's the degree of the first one? Okay, you only look at the variables. So what's the degree? You only look at the variable. 2.
Yeah.
What's the degree? What's the degree? What's bigger, 2, 1, or 0? That's the answer. Julie? Remember, we say a degree of the monomial is the sum of the degree of the exponents of the variables, not the numbers. We just ignore it. Okay. Cool? All right, this is box 4. Let's do them. Hey, this one's easy. What's the degree of this polynomial, Chris?
4.
4, because 4 is bigger than 3. That's easy. If the ones that are challenging are the ones that have multiple variables. Hey, this monomial is degree. This one is, and this one is. Which bigger, 2, 1, or 1? No, it's degree 2. And the next one is, it's not even a polynomial, it's a monomial. It's a trick question. Right? Thank you for noticing that. And no, Mr. C did not do that on purpose. All right. I don't know why I did that, but certainly it wasn't on purpose. All right. Next new thing. It's easy. It's called standard form. Standard form in a second here. Standard form is when you take a polynomial and you rewrite it so that the monomials go in decreasing order. Standard form is when you take a polynomial and you rewrite it so that the degrees go in decreasing order. I'll give it to you. So I just wanted to show you first. It would be 3x squared plus 2x. Their standard form. Okay. What's this one in standard form? It's not 8x.
Negative 8x squared.
Negative 8x to the 4
Plus 2x.
plus 2x cubed.
So all we do is just look around.
You just go 5, 4, 3, 2, 1, 0, or whatever the numbers are. Notice, I'm not looking at the coefficients. I'm looking at the degree of each monomial. All right. Somebody do it.
It'd be what?
It'd be.
It would be what? It has to go from highest to lowest. What's the highest monomial there? Absolutely not.
Okay, so it'd be 2. It'd be the same thing.
What is the highest degree monomial? X to the 4th.
Oh.
That's a 4th degree monomial. So x to the 4th, keep going. What's the next highest?
X to the 3rd.
It's not an x to the 3rd, it's 2x.
2x to the 3rd.
So plus 2x to the 3rd, keep talking. You forgot, we went 4, 3, then we're going to go 2, and then 0. So there's your standard form. You guys were not giving me much confidence there that you can do this.
Wait, I thought we had the exponents.
We do go by the exponent. Exponents tells us the order, and then we simply take the monomials and put them in that order, but we need to maintain whether it's positive or negative. The only one here that's negative is the 2. Who's lost? We good? I didn't have you write this down. Why? Because it's easy, but write it down. In box 5, you got a little bit of room, squeeze it in.
Can we write it in the box here? Can we write it right here?
Yeah, that you could write it next to box 5 as well. Okay. Standard form. You're going to hear me say this. This year we're going to do basically 3 types of equations. One's going to be degree 1, one's going to be degree 2, one's going to be degree 3. Yeah.
Can I try the first one?
Go for it.
8x of the second power plus 2x minus 3.
Is he right?
Yeah.
Second one?
4x to the power of 2 plus 3x.
And the last one?
1x to the power of 3 plus 4x.
Who's lost? Okay.
Wait, I didn't finish writing down the definition.
Standard form is just you put the monomials in decreasing order of their degrees. All right, now we really do have one thing left, except it's in 2 parts. And it's, can you copy down a table, 2 of them, and can you apply the table to polynomial? All right, here we go. So we're going to give you 2 tables. 2 tables. One is going to be, well, the names are going to be applied to a degree. So degree 5 is going to have a name that's different than degree 2. So we're going to have names for the degrees, and then we're going to count how many terms. 1, 2, 3, 4. We're not counting exponents. We're just counting how many monomials there are. That's how many terms. And that's going to have a name. By the end of Christmas, you'll remember all of this, but you're certainly not going to remember this by Wednesday. So that's why you need to bring this in on the quiz. So I'm going to show you the tables. We'll start with degree name. So a degree name, here it is. This is box 6, whatever it says. Make this table. You don't need to put the example unless you want to. So if you are degree 0, you're called a constant. It's your name. Start writing.
Which box? Big or small?
Okay, you're smart enough to read that.
Right.
If you're degree 1, we're talking about a monomial. If you're degree 1, you're called a linear. If you're degree 2, you're called a quadratic. If you're degree 3, you're called a cubic. And lastly, if you're 4 or higher, you simply say 4th, 5th, 6th, whatever, and that's your degree name. There needs to be some pencils moving. You're not going to remember this.
So wait, degree is.
Degree is, so you're going to look at the degree of the polynomial. If the polynomial is degree 2, you're going to say it's quadratic. Classifying polynomials. Constant, linear. I'm going to have this, for those of you that are very slow, I'm going to have you, I'll have one slide that has everything written on it. Okay? So this is an example of a constant. Hey, this polynomial is degree 0, constant. Hey, this polynomial is degree 1, linear. Hey, this polynomial is degree 2, quadratic. Degree 3, cubic. degree 4, it is a 4th degree. If it had 5, it'd be a 5th degree, 6th degree, 7th degree, so forth and so on. Okay, the second one is called how many things you have, how many monomials. Here's the table. If you have one thing, just a monomial, you call it a monomial. Duh. If you have two things, you call it a binomial. If there's 3, you call it a trinomial. And if there's more than 3, we just don't give them any names. We just call them polynomials. This year, we'll be dealing with monomials, binomials, trinomials. Monomials, binomials, trinomials, polynomials. You're going to hate trinomials because that's what we'll spend most of the time on. A quadratic trinomial will be your nightmare this year.
So can I fight trinomial?
You can try to fight all you want, but unfortunately, they continue to fight all the way through the end. Okay, so I'm going to switch slides, but I'm going to have both of the tables still up. Okay? So here is the degree name. Here is the number of terms names. All I'm going to do now is give you a polynomial, and you're going to tell me what's its degree name, what's its term name. Okay? The easiest way to do this is to put the numbers in standard form. If you put them in standard form, then it kind of just falls out, and it's easy to do. Okay?
Wait. On the last slide, there was an N. What was the N for?
We just call it a polynomial. Anything bigger than 3 terms, we call it a polynomial. I'm going to jump to some examples. Okay, they're still there. You see them? Okay. Hey, what's the degree of this polynomial?
Quadratic.
What's the degree of this polynomial?
Linear.
It's linear. The highest exponential power is 1. That makes it linear. Hey, how many things are here?
2.
Therefore, it is a
Linear binomial.
binomial. If we write it in standard form, what would it look like? It's got to go in decreasing order. It would look like that. Its degree name would be, it's to the first power, so it's linear.
Linear binomial.
And there's 2 things, therefore it's a binomial. That's what you got to do tonight for homework.
Okay.
Okay, let's do another one. What's this in standard form?
4x.
Power 2 plus 3x.
Okay. What's its degree name?
It's quadratic.
It's quadratic. How many things you got there?
Binomial.
2, so it's binomial. All I'm doing is I'm putting in standard form. When you put in standard form, the one on the left is the degree of the polynomial. So I got to do is read that number, it's quadratic. There's 2 things separated by addition, subtraction. That means 2 things, it's a binomial.
You have enough time to work.
All right, I got to show you this one right here. This one's the tricky one. Put that in standard form.
5x. 3.
Oh, wait a minute. There's a 7x and a 4x.
So
What's 7x and 4x? So we can have inside a potential that we can combine like terms. Everybody watching? 7x and 4x is, so when you put this in standard form, the 4x and the 7x could be combined into 11x.
At our bell.
We got about 3 minutes. Who's lost in what I just did right there? I just combined like terms. Hey, what's the highest power now? So therefore it is a cubic by degree name. How many things do I have here? 1, 2, 3. Therefore it is a trinomial.
Oh, okay, that's easy.
If I show this to pre-algebra students, they will cry and poop their pants, right? This is so weird. It just needs to be explained to you, and then it's not that bad. Chris?
Could I leave it on its first form and you be fine with it?
You can, but I am for homework ask you to put it in standard form and this. Yes, but you could absolutely get these 2 answers by thinking it through in your head. Yeah.
Are we gonna even hear?
Here. All right. We'll do these real quick. Standard form, x squared plus x.
It's 2x.
Degree name,
It's
what's the highest power?
quadratic.
It's quadratic. How many terms? It's binomial. Standard form, oh wait, combined like terms.
So
3 minus 5x.
But we would write it as negative 5x plus 3 in standard form. What is it?
Linear.
Quadratic would mean it's got something to the second power. It's linear, and it's a binomial. Last one. Standard form.
X to the power of 3 minus 3x plus 4.
Okay. Therefore, it makes it a highest power.
Cubic
It is cubic
trinomial.
trinomial. It's a cubic trinomial. All right. That's it. Here's your worksheet.
Good afternoon.
Take your attendance.
So much.
Do it. Do it.
Because Riley said what
She had the volume on and she heard Rylan saying bad things, so she could say it at
Lunchtime.
lunch. Or stay here. All right, e-learners, if you have any questions, send me an email. Questions, Haley?
No, I think I'm good. The only thing that I do have a question on is the first one for the homework assignment and the standard form of it. I got how to do the degree name and the term. I just don't understand how to do the standard form for it.
Okay, so standard form needs to go from highest power to lowest power. So the highest power there is p to the fourth, right?
3p to the fourth.
So I'm sorry, yes. So 3p to the fourth, then it would be minus, in fact, this one is in standard form. Notice it goes 4, 3, 2, 1. No, you don't have to rewrite that one. It's already in
Okay.
standard form. All right?
Okay.
What's for lunch?
Probably peanut butter and jelly sandwich.
Nice. All right, have a good weekend.
You too.
See ya.